Hello, everyone, and welcome to today's presentation. We are here part of the IMAC virtual conference, and my name is Marco Perez, and I'll be spending some time with you showing some tricks and how to take some measurements on the go. So without any other delay, let's get started. I'm gonna share my screen here. And first thing I wanna show, I brought here a couple of toys and a couple of things we're going to be using during this presentation. So we have a variety of sensors. I try to look at some really small sensors that are made by PCB. Like you see this little teardrop accelerometer. There are different versions of this kind of sensors. We have this little tiny one, which is almost hard to see. So I'm not going to be using this one, too small. And we also got some high sensitivity ones that are also small. So we'll play with them throughout the presentation. We minimize my camera, get PowerPoint going. And so today we're going to talk about, how to perform sound and vibration measurements on the go. And to do that, we're going to be using our little gadget device here called the digital ICP. It's our 485B39 model. And what this little thing does, it allows you to digitize a large variety of dynamic sensors. So it could be a microphone, it could be an accelerometer, it could be an impact hammer, and you can easily connect those sensors to pretty much any device out there. You name it. The picture shows measurement being done using a cell phone app. Today, for this presentation, I'm going to be using a Windows PC software. It could be a tablet app as well. And the interesting thing about the digital ICP signal conditioner is it allows you to stream data through the USB port. And so it's truly a plug and play device and doesn't require any specific drivers. We're using Class 1 Pro Audio standards. So this is pretty much embedded on any device out there, meaning it could be a Windows operating system, an Android or an iOS device, or even a Linux computer. And it allows us to basically take benefit of all the existing IEPE or ICP type sensors. So we can take benefit of a proven technology that's been around and existing sensors that you may have already. Those sensors are calibrated, so you get the best-in-class accuracy. You can perform measurements up to 20 kilohertz. So that pretty much covers the wide range of most sound and vibration applications. You are not limited in terms of dynamic range. You're not sacrificing anything when it comes to data quality. You get the best of digitization, a 24-bit A to D converter, and anti-aliasing filters, and of course, the key thing here is the portability. How small and how easy this device is a low-power device as well. And to demonstrate that, what I want to do is just go along with you on 3 measurement demonstrations. We'll be doing one, which is basically a system check. How do you check, make sure your measurement system is working properly. Then I'm going to try to measure a consumer product device. I have an electric toothbrush that I just purchased the other week, and I want to make sure what they promised me is really true, and see how they advertise, and if it makes any sense how they claim the benefits of it. And last but not least, I'll be sharing a glass of wine with you and trying to see if I can detect how much wine is in my glass without looking at it. Well, I'll be looking at it, but doing an impact testing, see if I can tell how much wine is in the glass. Let's go. So for the first demonstration, what I'm going to be using is a handheld device, a 1G portable handheld shaker. So that will produce a known frequency at a known amplitude of 1G RMS. And I'll be capturing that with my accelerometers that I'll be using throughout my presentation. So let's go there. Demonstration time. So I'm going to switch screens a little bit here. Get to my camera so you can see what I'm doing. What I'm going to do is get to my, take my little dual channel digital ICP device, plug into my computer. I have a USB port right next to it here on the back. There you go. Got the little green light here. That tells me everything is powered up. And I have a sensor. Oops, it just fell off. So I'm going to take these two sensors and I'm going to use my portable calibrator to make sure everything is up and running on my setup. I'm going to use a little bit of petrol wax to mount the sensor to my calibrator. And of course, never forget your Swiss Army knife. I'm just going to grab a little bit of a wax so I can stick the sensors to the calibrator. So we got one sensor done. Get my second sensor here that already had some leftover wax. Okay. I got the two sensors connected. You know, it's really amazing how small those sensors are if you compare to my fingernail here. Don't know if you can see. Those are basically the size of my pinky fingernail, and the cables are so small, so delicate, and so robust at the same time. So I'm taking this little scope adapter just to get to a BNC connection. I'm gonna get that into my cable. Just bear with me for a second. Okay. I'm gonna get on my, just wanna make sure I got the sensors on the right channel. So I got two channels. Gonna get my second one on my channel 2. And let's minimize this a little bit and go to our software. So I'm gonna use SpectraPlus-SC software for this demonstration. It could be any other of your favorite FFT software. At the end, I'm gonna share with you a list of different programs that are compatible with our device. Okay, so at this point, let's fire up the measurements. Oh, let me just check a few things. My I/O, I'm gonna make sure I select the 485B39 as the input device. So the software sees it as an audio device. So I want to make sure I'm capturing the vibration through my device and not through the laptop microphone. So I want to make sure that is done correctly. Also gonna make sure I got the right calibration for each sensor, which is already there. I've done that ahead of time. So let's just hit run on the software. And right now there's nothing happening. What I'm gonna do is fire up my 1G handheld shaker and see what I get. So I have left channel on the left, right channel on the right, and I should be reading a 1G on both channels. Just want to make sure my window is correctly. Yeah, I'm using a flat top window. Gonna hit run again. Just gonna zoom in a little bit so you can see my calibrator frequency there. So looks like we're getting, let me hit stop. Looks like I'm getting almost like a perfect 1G reading on the right channel. 159.2, that's good. And I'm getting 1.06 G's RMS. On the left channel, I'm getting, well, a little above 1G, but I'm reading a peak value. So I can fix that. Just gonna go here on my scaling and gonna say I'm gonna read RMS. Let me just repeat that again for a second. It's much better. I get much closer to a 1G reading. Okay. If I get, let me get a readout, 159.2, 1.06. That's pretty close. So everything is connected. Everything is, I'm capturing data. So that's a good sanity check. Make sure your system is up and running. Your channels are properly set up. So we are ready to take on a real world measurement. And our first demonstration, let's go here to the presentation. What I want to do is to check on a consumer product, and I was thinking about, what would be something interesting, and I just bought this little toothbrush, and this is an electric toothbrush, and that comes with two modes or two speeds. One is the cleaning mode for exceptional everyday cleaning, and the second mode is the massage mode, which gently stimulates and massages your gums. Very beautiful. And let's see how it let's see how it works. Okay. Let's go back to demonstration time for a second, and I'm gonna show the camera just that you know what I'm doing. So I have the toothbrush, very simple, and it has two speeds. I can press the button one time, and I can press the button a second time, and it goes through the different modes. Now I'm going to turn it off, and I'm going to mount the sensor on the head of the toothbrush. So I really want to get a feeling of how much vibration am I getting through the head of the toothbrush into my teeth. To do that, I'm going to get my sensor back here again. So I'm just going to use one sensor for this experiment. I could use two if I want to. I could even do like a microphone and an accelerometer. So I'm going to take one of the sensors, this one. Let me move this away or out of the way. I could use one of these microphones as well. Not now. So what I'm going to do, grab a little bit of wax and just get a little bit of wax on the head of my toothbrush. This looks like a cooking show, right? Just the difference, I'm not cooking anything. I'm just taking some silly measurements on this household appliances. And you can do all sorts of things. When I was basically playing with this toothbrush before the webinar, you can mount this, you put the sensor over here next to where the motor is, and you get a very clean measurement. But definitely when you measure at this point, which is right at the brushes, there's really quite a bit of amplification that you get through this beam or through this brushes. Basically, this is where the thing connects into the engine. So we're gonna do that. My sensor is properly mounted, and I like to use the Petro wax because the surface of the head is not perfectly flat, so I can, with the wax, it's very forgiving, in terms of, getting to a surface that has a little bit of a curvature. I could be using super glue, but then super glue is not as forgiving. So I like this mounting method, and let's see if we can get a good measurement. Okay, so I need to connect my sensor to channel 1. And let's go back to our software for a second. And I'm going to load my configuration. I have a configuration preloaded for this. Okay, where did that go? Hold on. Okay, Sonicare setup. Okay, so now what we got on the screen, on the left side of the screen, I have my time plot. On the right side of the screen, I have my frequency spectrum. I'm gonna hit run on the analyzer. So right now there's nothing going on, just the toothbrush is off. And if I can turn it on right now, so you can see on the screen, I'm taking about 50 averages, so that's good enough. I'm gonna stop the analyzer, and I'm gonna stop the toothbrush so you can hear me. And let's just bring over the camera for a second. You can see my settings again. So here's what I did. Just got the toothbrush here. The reason I mounted on this side is because it has this movement that basically goes, sideways on when you are brushing your teeth. So I selected that direction as the primary direction of vibration. And let's see what we got. Let's see if the data makes any sense. And it does. So you can look at the time data. I'm going to zoom in a little bit so we can look a little bit, see what does that look like. So it's a pretty periodic movement. So I imagine the guys that designed the toothbrush had this a little motor there, just at a constant speed. And when you look at the spectrum, let me blow that up a little bit. You can see there's a fundamental frequency which is 253 hertz. Yep, that's what it is. And a bunch of harmonics. So 253, then you got another harmonic at 500, 500 and 750 or 760. So that goes all the way to my measurement range. So I'm sampling this at, let's see how far am I going on this. Yeah, I'm going up to, I'm sampling at 8 kilohertz, and so I'm going all the way to 4 kilohertz, which is pretty good. I think I got the idea, got a fundamental driving speed, and that's pretty much it. It's a very periodic actuation. And let's just save that for the sake of, we can look at that later. And I'm going to try to measure now the second mode of my toothbrush. So let's hit run again. I'm going to turn the toothbrush on. That's the massage, not the massage. This is the cleaning mode. And this is the massage mode. And look at that. There's all sorts of things going on here. So it's a pretty periodic vibration. I'm going to stop for a second. I'm going to show you the camera so you can take a good view of what's going on. Don't know if you can see the brushes are going crazy. And that little doo-doo is to indicate it's been like 30 seconds. So I'm gonna move to my bottom teeth. But that's the idea. I'm gonna stop the toothbrush so you can hear me better. And let's take a look at the data, see what we got. So what it looks like here is that if I zoom in a little bit, I can still see like a fundamental frequency, a little bit similar as before, but it's that all sorts of sideband harmonics. And if you take a look at, let's so my fundamental is at 260 hertz, which is right here. And if I look up, so let's say this is 260, and this the next harmonic, the next peak is at 288. So those are equally distant peaks, which indicates there's something else going on. And if you look closer here on the lower frequency part of the spectrum, we are going to just like 30 hertz, 30.8. Let me put a marker there, just we can makes it easier. 30.8, almost there. I guess my marker didn't look precisely what it is, but so that's what it is. You know, we get this 30 hertz excitation on top of the main excitation of the toothbrush. In other words, if I go back to the claim, you know, when they sold me this, you know, they said, okay, you got the clean mode and you got the massage mode. So what the massage mode did, it added a 30 hertz on top of the main speed. So I'm getting this 30 hertz massage on my gums, and that probably does a good job on getting the gums stimulated. So that sounds pretty good. I'm pretty happy. And hey, I found your secret. So I know how you make your toothbrush, at least the the dual speed toothbrush. They have a version that's 5 speeds or 7 speeds, which I doubt it does something much different. You know, maybe it goes a little faster, a little slower, who knows? But definitely the 2-mode toothbrush has a very clear definition of what it does. And I'm gonna save that data for later. And let's move on to our third demonstration of today, which is, it's gonna require some special tools. Let me go back to my camera. And for this demonstration, of course, you know, we're gonna need some good Spanish wine. I brought here some Infinito, which is a wine from a region of Spain next to the Mediterranean. It's called Jumila. So when you look for your favorite wine, you know, look for this denomination of origin. And this has absolutely nothing to do with the testing we're gonna do, but it's just a good wine, best kept secret, Spanish wine, great wine. And the question we have today is, how much wine is in my glass? So right now there's no wine in my glass, but we're gonna take care of that in a minute. And the thing is, depending who you ask, you're gonna get different answers, right? If you ask the optimist, they will tell you the glass is half full. And if you tell the pessimist, they're gonna tell it's half empty. But hey, you know, we're in the middle of engineers here. I'm an engineer. I'm gonna make a joke about engineers, because if you ask an engineer how much wine is in the glass, he's gonna say, well, the glass is twice the size what it needs to be. And that moves on to, okay, better to work with a full glass instead of a half glass. And then what we're gonna do is, like, you know, can I tell if I go through my wine drinking, you know, can I tell how much did I drink? You know, I'm gonna start with a full glass of wine, and and see if we can tell the difference by just checking the resonance of the glass. And let's give it a try. And here's my hypothesis. As you drink, you are removing mass from the system. As a dynamic system, I expect with less mass, I expect the frequency to go up. So I'm gonna expect the sound of the glass to go up in the pitch. So let's do it. Let's go here to our camera again and get some wine ready here. So for this test, it could be any wine, but better do it with a good wine. And once again, we're gonna use our mighty accelerometer. Just gonna get it out of the toothbrush, put a little bit of wax on it, and stick it to the side of the glass. And just in case you're wondering, this is being recorded live, and I'm gonna hit the glass with a hammer and measure its resonances. And hopefully I don't break the glass. I asked for a crystal glass, but our marketing budget was a little limited this year. I only got this standard, I think it's an IKEA glass. And I put way too much wax on it. Well, I truly recommend, if you're watching some of the webinars we got on a PCB.com website, there's a nice presentation we did recently about sensor mounting. They did a much better job than I did. But hey, I guess I'm being too modest, except that I put too much wax. Here's my accelerometer. It's right there. And and here's my hammer. So let me get my hammer with a cable. I'm gonna use just a standard BNC cable. Go on channel 2. So most people would use the hammer on channel 1. So the hammer is gonna be my trigger. As long as I tell the software from which channel I'm triggering, and bang, bang. So everything is working. So I just want to mention, the impact hammer comes with different tips. So we got some softer tips, we got some harder tips. I'm using the metal tip today, trying to get as broad frequency as I can. Some of the softer tips will give you more force, but lower frequency range. So the white tip should work fine, but I'm using the metal tip. Some of the other tips were too soft, and I couldn't get anything out of the glass. Let's switch to the software for a second. I'm gonna load my configuration. Okay, and so I'm gonna look at the traditional frequency response function, left and right channel, coherence, that kind of stuff. So to be sure everything is all right, I have my triggering set up. I'm doing a trigger-based measurement on a positive slope using my force channel, which is the hammer. And I'm gonna take I think 4 or 5 hits. And just to be sure I have the right sensors on the right place. I have my accelerometer on the left on channel 1. And I got my hammer on the right, so everything looks good. So let's just say, okay, let's see if it works. Let's say run. And that's a good sign. If you look on the corner of my screen, it says waiting for trigger. So it's waiting for me to hit the glass. And perhaps let's see if we can get the camera so you can see that live in action. 1, 2, 3. There we go. Beautiful. So we got my first hit, almost perfect. You see on the top channel the ringing from the accelerometer. On the bottom channel, the impact from the from the force hammer, very sharp impact. And on the right, I can see 1, 2, 3 peaks already. So let's hit a few more times. So that was my first hit. Let's get a second hit. Gotta make sure you're hitting on the same place, which I don't remember where I hit the first time. So let me start it over again. First hit, second hit, third hit. There was a little bit of a double hit there. That's all right. It's my fourth hit. 5, 6, 7. I think that's good enough for what I'm trying to demonstrate. So what I can see here on the screen, this is my frequency response function. There was a little bit of a big drop here on the coherence at an anti-resonance, but overall the coherence is pretty good. Too good to be truth. Yeah, 0.99. Wow. So I got a first peak over there, second peak, and a third peak. I'm gonna save that curve. That's gonna be my set number 1. And here's the best part of the presentation. I'm gonna drink some wine and see what happens. Fantastic. Sorry, guys. You can edit the video a little bit later, because if I drink too fast, it's going to be terrible. But anyway, let's get on a drink. I'm not doing any of the swirl because it will unmount the accelerometer. So you can see the accelerometer is still hanging there. I want to make sure it's on the right position. So, okay, let's. I'm not gonna drink all the wine right now. I'm just gonna get most of it out. Woo, what a mess. Okay, I think we are ready. The glass looks half full, or a little underneath the middle mark. And let's get ready for our second measurement. So I'm gonna go back to the analyzer. I'm gonna hit run again. And just that is the previous measurement. So that's what you're seeing on the screen. And it's waiting for trigger. It's pretty good. So let's hit it. Let's get the camera. Let's go our first hit. Ooh. That was a double hit. I didn't like it. Let me stop and run again. Another double hit. You see, that's what happens when you have too much wine during the testing. Gee. Okay. Come on, Marco. You can do it. That was good. 3, 4, 5. Okay, let's stop the measurement for a second. And I can tell right away here that the sound went up. You can see the green curve was my previous measurement. And if I zoom in, there we go. Let's see, let's keep a big zoom here. You can see my frequency went from 2000 hertz to 2120, 2146. If I look on my second peak, there we go here. Let me zoom in. And we got two peaks there, 21, 21.52. I think that's the one I just saw. Sorry. Let's look at the first peak. Yeah, there we go. So we had a first peak at 761 and went up to 800 hertz. So that's the concept. So I proved the concept. Yes, there is less wine in the glass. And I'm going to save that. Let me save that measurement for a second. Let me zoom out. Okay. I'm going to save that. And let's drink a little bit more. Or, okay, I should not drink anymore. Let's just get all the wine out of the glass. I'll drink a little later after the presentation. And just one more measurement. So I have my two measurements saved over there. And let's do our last measurement of the day. Camera. Okay, let's do one more time. 1, 2, 3, 4, 5, 6. So got lots of double hits. But let's see if we, yeah, not much difference now. Interesting. So definitely looks like what we were seeing was primarily we had the wine interaction with the glass, and not too much now once the glass was empty. Oh, we got a little bit of a shift there. Not a lot, but yeah, there we go, the blue curve. So we went from 800 to 810. So yeah, I don't know if it's a linear system, what it is, but definitely, you know, I can tell there's less wine in the glass. So thank you very much. That concludes our demonstrations for today. I hope you enjoyed. And this presentation was only possible with the help of the Moto Shop, who helped me with the equipment. So we got a list of the items that I used during this presentation. And again, you know, I used one of the softwares that I had available, but there's a large list of FFT analysis software that you can pick from. I got some links there, and including, I mean, you know, you could develop. You know, a lot of people have used environment or programming languages such as MATLAB, LabVIEW, Python, or LabWindows CVI to write their own analysis tools. So we got some links here. We got even some example code in LabVIEW. If anybody would be interested, you know, just you know, send us an email. We can share this information with you. And thank you very much for attending this virtual live demonstration of digital measurements on the go using our digital ICP signal conditioner from the Moto Shop. Thank you and cheers.